Dear ladies and gentlemen, dear developers, a warm welcome from the Embedded Wizard team to today's Masterclass Monday session. Today we will be talking about a very important topic in the cycle of developing a whole GUI, which is the testing. So today the automated GUI testing will be covered, and in detail our head of GUI services, Rudolf Leberfinger, will guide you through different tests that have to be fulfilled in order to get a complete picture of a tested GUI. So, thank you for attending today. Questions we'll be having afterwards, as usual. Of course, this session will also be recorded, so don't get stressed out if anything is not very clear at the very moment and you need some time to repeat it. There will be a video recording afterwards available on our website. And Rudolf, our head of GUI services, has a vast experience in testing, so I'm pretty sure he will be guiding you the best way he can through this topic of testing. Welcome, Rudolf, and the stage is yours.
Thank you, Christine, and welcome to everybody joining today's masterclass. As Christine already explained, we want to talk about automated GUI testing in today's session. To give you some explanation about GUI testing, I would use an example which is using the Embedded Wizard test framework and show you with this example how we can do record and playback tests, how we can do own written tests which are then learned and which are called in a verify process. I can talk about test of the GUI states, test of the GUI graphical output, the test during animations, as well as the test of the device interface. And for all of these tests, I show you then how you can do the automation of these GUI tests. Let's get started with this. I prepared for you here our Embedded Wizard test framework and launch here the sample application which comes with the test framework and show you with this example how we can do the tests. So first of all, in the project you see here you have your standard GUI application. And if you already have a GUI application with Embedded Wizard, then you simply can also add here the test framework by adding here the unit tests, which contains all the bindings for the test framework. You then add, in addition to your current profile, a few additional profiles for doing the testing. And then you also can add a unit where you write your own tests in. So you see that the testing is fully separated from your original GUI application. When we talk about testing here, how this is done, let's first take a look in the profile test recorder. The test recorder profile, it says that the application class belongs to test play, a rec play runner application. That means here the real Embedded Wizard GUI which is started is coming from the test framework. And inside this profile, then you see that there are a few macros which are controlling here the test framework to know what you want to perform. When you now start such a profile like here the test recorder, then you simply can start it and it will then call your application to do something with the application. But first, let's take a look on the application itself, what the application is doing, that you know also what we want to test. This application, it just contains a few buttons. So here a toggle button to turn on a menu. And in the menu, you can scroll and you can select here different menu items. Also, you can change a language, or you can start an animation. And in addition, we have one button which can control a device, but that's more or less when you are connected to a target. That's a quite simple application, but I guess it's enough to explain how this can be tested. So we see I'm now in the profile test recorder and I want to record a test. I simply start the prototyper with the application class, which is the test framework in this case. The test framework launches your application, and now you simply can interact with the application, and the test framework will record the sequence you're interacting with. Also here start an animation, turn off the menu and close it. All of this is now recorded, so a huge list of user interaction with doing automatically also checking what's currently on the screen and what's the current states. And now you easily can run a test playback. And when you do this, so you want to know if everything behaves in the same way, also you simply start the prototyper, which is now running your application in playback mode. And it will do exactly the same as I did before during recording. So let's wait a little bit until you start the first user interaction, until here the whole sliding is done. Then I guess I did here a selection of the user, then a language change. And then I started the animation, stopped it, closed the menu, and then the test is passed. I can close the prototype and take a look here on my debug window, and I see that the whole test is passed, everything is fine, so no error occurred, and I'm fine. I've already done my first test together with the Embedded Wizard test framework. That's now a very, very easy way of performing a test. So you just define the test sequence by interacting with your application. Everything is recorded in the background, and you easily can do a playback of this recorded tests. Let's now turn a look on the next level of GUI testing here, which belongs to tests you can program by yourself. Therefore, I go to the unit tests and let's take a look what's done inside this unit. First of all, writing own tests. You also want to have, for example, something like a real state check of everything you have inside the UI. With states, we can talk about states, for example, for a button, where you see, is it pressed, is it activated, is it focused, what are the bounds of the button, or for a menu item, is it visible, is it not visible, which text is shown, and so on. And to do this, here we can simply do a trace implementation for our visual components. So what we do here, we now take, for example, from our application, a variant of our application toggle button with the variant condition trace. So this is only generated when we really have trace activated, and this is done within our own test profiles. Taking a look into this toggle button trace implementation, we see that the only thing we do here is that we override the handle event, and in this variant of a toggle button, we now have an additional implementation. So that means we also check here, is there a tests trace get status event, which is sent from the test framework itself. And when this event is delivered to any toggle button, then the toggle button simply extends the existing status attributes by its own attributes he wants to add. So in this case, we just add the object name that we know it belongs to an application toggle button. And then we add attributes like the bounds of the button, then a bool attribute like the active state, is it true or false. A next attribute is the string which is shown on the button, and a next attribute, it's the status attributes of my toggle button. Okay, same we do also for the menu item. Also, this is overwritten. It also implements the handle event and doing in principle the same, just that it now adds the menu item as the object name, and the events, the attributes which are added are the bounds and the caption. That's all we want to do here in this simple example. For a big UI application, for sure you want to know here a lot of different states, and it belongs to you which additional trace information you want to add here. What's now very important, let's take a look how these references could look like. Therefore, I want to get here in our test data and take a look in the references which are already done here, and just open here any of these reference files, and you see here that's now the status string which is really recorded in the test. It says that here the toggle button bounds belongs to these values, its active state is true, and the string shown is on. Okay, that's related to the status information. And it's very, very helpful because maybe such of these status informations does not really have an effect on the graphical output. It's in the background, but during the test, you can get a lot of information and you know exactly what happens inside your application. Yes, a next thing I want to talk about here is now the graphical comparison. And I can show you this also when we really take a look on any own written tests, which are then this learn and verify mode I talked in the beginning about. Yeah, let's take a look inside our tests how these can be built up. First, I have a test runner and have a runner configuration. In this runner configuration, I give them a name. It's my test configuration example. And in the init method, I simply then register for the runner different test suites. What's important, you can also structure here the tests into different suites, because it's very important that you build up the test also here step by step, and you easily can extend your whole GUI testing by adding one of test suite after each other. And if you do not want to test everything, you simply comment out later some of the test suites and just perform a few of them. When you register a test suite can also be initialized with a dedicated style and a dedicated language. And this also allows you to run then the tests with different styles and with different language settings, and this fully automatically. Now let's take a look in one of the test suites. So here, first one is the application test suite example, a very simple one. Also here I say what's now the view class, and the view class, it means what should be tested. And in this case, it's our application. So that's our GUI project. Then I say the type of the test suite, and that's an acceptance type. We also have here multiple types, but the acceptance, it's very, very convenient because it simply checks if the behavior is the same as before. And you can also differentiate later on between different types of testing. And then we give the test suite a name. We just say it's our application test. And same as for registering for the runner, we do it in the test suite itself, in the init. We register now for the test suite different test cases. And we register here one test case example and one test case device example. Now let's take a look on the test cases, which belongs to a test suite. And the test case example also now registers different test steps by just adding them with a name and with a slot method, which is then called whenever this test step is performed. These are now standard Cora mechanisms, and you easily can implement all the tests as soon as you are familiar with implementing a GUI with Embedded Wizard. What's done here, you see already, you add a step, give a name, add here the slot, and the last parameter, it's then some delay. So that means you can also force here some timing to be passed between calling the different test steps. And whenever a test step should listen for something, then also we can add a test step asynchronously, and that's done later on for the animation tests. And here it's listening for some certain events. And for sure, they also have some timeouts. If the event never will appear, then the test step will be executed after timeout. But what happens now in a single test step? First step we add here is an open menu, and now I go into the slot open menu. This step now just checks if the view class, so the class to test, is valid and it's really of type application. If that's not the case, we just fire an assertion and say that the application is not created. And the next step, we simply send a key input. So there are provided functions like send key, and what we are firing here is the enter key. The next step, it's then to check if the menu is opened. So with the first sending of the enter key, we expect the focus is on the menu toggle button, and when we press enter, then it gets activated and it is opening the menu. Now we have here a test step which should perform a check. And what's done here, we say assert check status. And what happens during this assert check status? Simply here, the test framework sends an event message to all active Cora objects, and they are listening now in the handle event, and then they just concatenate the existing status string with their own status. That's what we have seen in before. And at the end, with an assert check status, you will get a big string which you can store as a reference, or you can then create the string and compare it with the previously stored reference to see if the whole status is still the same on this test step. And the next one, and that's now the important for the graphical testing, you say assert stack check screenshot. And with this assert check screenshot, simply a screenshot is taken with the name of the current test step, and then it's also possible to record it, this screenshot, as a reference. And when you perform a verify phase, then a new screenshot is compared with the old one. And now we want to take a look also on the references which are already built here. And you see there is a lot of graphical information also, like this PNG. And that's the first one, which says it's our acceptance application with the style profile, with the language default, and it's the application test case example in the step check menu opened. And that's now our screenshot we taken. And this screenshot, I'm just opening it and showing to you. That's now the screenshot of our application after the menu opened. And that's a quite convenient way of testing GUI applications, because the visual impression is one of the most important things here for the GUI applications. When we take a look on other screenshots, let's go a little bit down. It's our test case capture screen. Yeah, that's nearly the same. Do we have others? For different style, for example, then you see that this is then done in a black and white style, so monochrome. Okay, good. That's related to taking a screenshot. Other things you can do inside your own written tests, for sure, that you have these simple assert possibilities. And here you can do whatever you want, like in this example. Just check if it's an application and check if the application main menu is visible. So that means that's no longer black box testing, that's really white box testing. You know about your application, and you simply can also here add additional code to check dedicated things within your current application status. And when you want to do other things like menu up, you simply can say also send a key or send a key asynchronously with 5 times, and each of the key presses should have a delay of 250 milliseconds. And at the end of each of this asynchronous key press, a slot navigate should be executed. And this is simply doing here an assert check status for ID. And then you can say for a simple test step that it's added also the ID, so you can do multiple things within one simple test step to have multiple references and multiple screenshots. Taking a look on this, you see that's the menu, the navigate menu down with the ID 1, with the ID 2, and so on. And for each of these IDs, we got here the related screenshot with the settings selected, and the next one with the IDs selected, and the next one with security selected. So that's just to explain you how you can do here dedicated testing in a programmatic way. And when you want to check, for example, a language change, that's also done here in this way with sending a touch event instead of a key event. And you simply can then also do here programmatically define the current touch position where the event should take place. During the recording, these event positions are done by just recording your user interaction. By the programmatic tests, this can be fully defined by yourself. Okay, now we talked about how to implement these tests by yourself. So you can really here build up your own big test suite, not just a few examples. For bigger GUI applications, this really can be a few thousand test cases if necessary. I want to show you how you now can do such a testing. And in this application, we already have the recorded tests. And now I check if everything is correct. So I choose the profile test application and start the prototype with the application. So that means I'm performing the test. Now the tests are running, and you see that here really all the automatic testing is done in the background. So the test framework is executing the test suites with the different test cases and all the steps defined in the test cases, and is performing here really all these checks automatically. You can run all these things in the prototyper, which is quite good to do a quick testing during the application development. And as soon as the test is passed, you get then all the results of the test also here in your debug window. That means what we have seen here, there are different test steps which are performed. There are some tests which force to do an error, and you get here the total result of the tests. And this result can be shown here in this way. It's not very human readable, but it's good readable for a machine or for an automatic test system like a Jenkins server. Okay, now I want to show you what happens if you really change something inside your application and the UI will no longer be in the same state as you expect. And the test should really find this. Therefore, I simply here change the position of my button, and maybe also here LED device. It's here with a string, and I add to this string a small s that it says device LEDs. So just a string manipulation. And now I perform the whole test again. And whole tests are done. You see that there are some failures in. There are some mismatch in the monochrome state. And now let's take a look what happens here. So let's go to our references and see what happens in here. That's our reference. And let's go to our fail. And now in the fail, we see what's really different in the tests. And it's important here, you can check there are different PNGs also for your fails and different fail references. In the fail reference here, you can compare with the original and see what's different. And I guess it's here the position of the toggle button. But more important, what belongs to the PNGs, and I simply change here to big symbols. And now we see that we get here the original one. We get here the new one during test, and we also get a differential image. And this differential image, that's now most important, it gives you a guide what's different between these two screenshots. The original one during the learn mode of the test. Now that's our verify mode after I did some modifications. And maybe you will find here that the button is changed and it's in a different position. But for humans, it's quite hard to see that this string is different. In the differential image, you easily see all the positions where any color changed. So black means no change at all, and any luminance factor means there is a change in the color at these pixel positions. And that's now a big benefit of doing GUI testing. Okay, that's now related to our topics of here having the graphical output. Our next step will be to talk about test during animations. And for this test during animations, I already have shown you before that we can define some asynchronous stuff in the test cases. So where we did this, set up toggle animation, check animation. Here, for example, yes, here just the animation step itself is checked. I'm just searching for it to show you exactly what I want to talk about here. Sorry, here we had it in the init. It's test steps which we perform asynchronously, and I already explained that here for the listening for the pulse animation ID, as soon as this is broadcasted, the related slot of this test step will be called. And now see how this is done. For sure, maybe you have a few animations inside your GUI application, and then related to all the effects you're using. This could be ready-to-use effects or some custom effects. You simply can also do here a variant of your effect, in this case of an application pulse animation effect. Also say the variant condition test, so that this variant is only created if we are in a test mode. And what we can do inside this, we, for example, override here the animate function of an effect, call the super to perform the standard functionality, and then we can check, for example, here that at the initial value, so the initial state of the animation, we then perform a tests animation sync and notify this ID, so notify the pulse animation ID. It means that at a defined step of the animation, this ID is sent as a notification. Then the test is listening for this and is performing exactly at this moment the related test steps. It means whenever this is broadcasted, then here the asynchronous step check animation is called, and this step check animation Let's see if we see it. Step check animation. I guess that's already available. I just search for it. It is here. And this is now really, that's not activated here. So what's doing, it's really just performing an assert check screenshot. So doing a screenshot exactly at this time of the animation. For the test automation, I now switch back here to the example and go to the test application. Inside this test application, you see that we also have here a project prepared for a Visual Studio compiler. And this allows us to create a Windows binary out of our GUI application together with the dedicated test scenario. And at the end, you get a binary which simply can be executed. And when you execute this binary, then all the tests are running in the same way as you have seen before in the prototyper, but now as a Windows executable. And this allows to add here the whole testing to automated test systems. And as an example for this, you can use a Jenkins server. And the Jenkins server then can easily here, as an example, get each drop from your repository after a new commit for the user interface application. Then build the whole stuff and perform the test by simply executing this Windows binary. And at the end, you will get all the results in the same way as you get it during the prototyping. That means in the test data, exactly the same results are in. So also here, the test results then are shown as an XML format. Good. Going back here, what we did for this already or prepared to have an easy integration inside the test application, there is also a batch folder where all the batches to perform a new learn mode are in, all the batches to perform here the run are in. So that means that are the typical batches integrated into an automated test system. And what happens here, I just perform here the run and then also give you an overview what happens here. First of all the generated code is deleted. Then embedded wizard is called to generate the whole code again for the current scenario. That means it will build code from really the test framework together with your test application and create a Windows binary and then automatically also run this Windows binary. And that's something which is quite easy to use in a fully automated environment. Yeah, now we are at the end of these sessions. I switch back here to my agenda and I summarize a little bit what we talked about. So, record and playback tests, it's the simplest way of regression testing. Then we talked about the learn and verify tests, where you implement your own tests within Cora language. During these tests, you can define which states of the GUI are added to your reference files and are tested. For example, button states enabled, pressed, or focused. Then you can test your graphical output. You have seen the comparison of screenshots and the delta detection, which is automatically provided and which very, very important for any testing of graphical user interfaces. Then you have seen the test during animations with the time control during the test to get really reproducible tests, because testing of animations, that's something which very often causes struggling in the tests. And I have seen here a lot of scenarios where simply long timeouts are added to wait until one animation is completed. But as soon as something changes, you easily get a lot of fails in the test and you don't know why. The next thing we talked about is the test of device interfaces. And here you have seen that you really can do a stimulation during the test via exactly the same API calls you typically use then for interacting between middleware and your GUI application. And the last thing was to talk about the test automation. And for this, a good way is to use, for example, a Win32 testing. And this easily can be integrated then into automated test systems like Jenkins. I hope you like this and it gives you a good overview about automatic GUI testing and how we do this with Embedded Wizard. So thank you. And now let us answer your questions.
Thanks, Rudolf. Okay, now we're coming back to our attendees and we're starting with question number 1. Question number 1 is, how can I simulate a swipe gesture?
Yes, how to simulate a swipe gesture. I can explain this. So it's also within our examples. I switch back here to the device, to the examples. One moment, I close all composers to get a fresh build. I go to the unit tests. And here now we can see inside our first test case example, I guess it was already in, and it was here a step swipe list down. And here we also have here the touch sequence as a member of our tests in the test framework. And this allows to define your own touch sequence by simply adding here new touch points and also the delay between the touch points. And that means you really get here, I guess it's really from top to bottom in certain steps and certain intervals. And that's a gesture which goes from top to bottom. And this can be easily then sent by send touch sequence. And then the test framework will perform simulating touch positions at these coordinates, and after the timing, the next touch position is here sent again. Okay, going back to the slides. Does this answer your question? I hope yes.
Great, awesome, thank you. I think that was clear. So question number 2 is already popping in, and this is it possible to test single GUI components?
Yes, testing of single GUI components. I also will switch back now to Embedded Wizard. And let's go to the tests again. And I guess here we also have an example which says few unit test case example. Yes, that's also in. I'm quite lucky. So we have this already prepared to show you how to do. And here just a few to test. It's now not the application. It's simply just the toggle button. And what does it mean? It means in the init, we just can here, for example, setup. We just create a new view to test, and it's our application toggle button. For the runner, we simply add the view to test, we set the focus to it, and then we perform the different steps. So that means we send touch events to the center of this view, performing here a test by touching on the center position of the toggle button. And the second one is just to check here the status, the screenshot, and also directly check if it's active or not. And in principle, it would be possible to also just perform this single test, and therefore I go back to my runner and I simply say I remove everything else and just perform now this one. And it will test only the toggle button. You have seen this quite quickly, but it just was the toggle button, nothing more. I don't save this, and let's go back let's wait for the next questions.
We are having more questions, but I want to conclude now with a third question. Get assured, like every time, if there's a question opened, we will be coming back to you one-on-one via email after this seminar. So, question number 3 is, can I use the test framework to create a GUI demo?
Yeah, that's also an interesting question. Creating a demo with the tests. Yes, going back here to this, for sure I have now the whole stuff again. Yes, for sure, you also can create a GUI demo with the tests, because the tests framework is really also perfectly suited to do here a dedicated sequence of what to do. You can do this either by here defining your own tests in the programmatic way, so to write this demo, or simply also to record and playback the whole demo. What's important, if you want to run it on your platform, then also you would need here a test framework which is adapted to your platform. So therefore, to say simply use it for demo, yes, for a demo running on PC, it's perfectly suited because you automatically can then create your Windows binary. For a demo on your platform, yes, but only if some modifications on the test framework, so some porting to your platform, is done. Okay, going back, I hope this answers your questions.
Thank you, Rudolf, for answering these questions. Okay, now we are coming to the end of the 8th episode of the Masterclass Mondays. From my side, there's only one thing left I want to mention. After this webinar window closes, you will be having the chance to send us your vote for the topic that you wish us to cover next week. So if there's any question left, we will be answering them via email. And if there's any other question you may have considering the embedded wizard framework or your GUI itself, please do not hesitate to come back to us. Here I display you the resources you need to dive deeper into and also the channels for us, for you to contact us. So we are happy to help in case you may have a question. And so I want to say thank you for your numerous attendance today from the whole Embedded Wizard team, and I wish you a beautiful rest of the day. Take care and bye bye.